Hello all, welcome to another session in Java in Depth course. As part of this session, I am going to cover the next topic of this session, that is Java is a platform independent programming language. For you to understand this session in a more better way, I recommend you to go through this previous session. Okay. So if you have already gone through the previous session, this session will become more, understandable for you. It doesn't mean that it's compulsory for you to go through this and come back here. But if you have gone through this and come back here, then the session can be understood completely. Okay. Otherwise, also you can understand this at a different level. Fine. Okay. So if you want to understand this session in depth level, then cover this topic and come here. Okay. Go through this previous session and come here. And another thing about this particular topic is I already have explained, during the introduction to Java that there are several advantages and disadvantages of Java, right? I told you that these advantages and disadvantages of Java I will not cover at that particular session point of time I told at that time. Rather, during the course, according to the situation needed, I'll be covering those advantages and disadvantages I told, right? I mentioned. So here is one of the such kind of advantages. Okay, one of such kind of advantages we have in Java. The main advantage of Java programming language is Java is a platform independent programming language. What does it mean? That means you can write the Java program in any computer machine having a operating system, and you can run it in any other computer machine having a different operating system or whatever it may be. Okay, you can write it anywhere and run it anywhere. Okay, so you can write it anywhere and run it anywhere. It doesn't mean that the code, for example, whatever the laptop I am using has an operating system like Windows 11. Okay, so let's say in my computer machine, that is my in my laptop, if I write the Java code, okay, using some tools and all, if I write some Java code, okay, and then tomorrow, if I take another machine having a different OS or whatever it may be, okay, let's say Mac machine, if I take, in that, do I have to write the same Java code in a different way for that particular different operating system? Not required, guys, okay? Whatever the code that you have written in your computer machine having a different operating system will work in another machine having a different operating system, okay? That means you have to write the Java code once in one machine, having one particular operating system or whatever it may be. And the same code can be copied into a different machine, having different specifications or operating systems, etc. And you can still run it there. Okay. It doesn't need you to write the code again for a different machine. Okay. The code need to be written only once in one of the machines and can be run any number of times in any other machines without doing any modifications as it is. This makes Java a platform independent programming language. Okay. So let me explain more about write once and run anywhere with an example here. For example, guys, I have three machines. Okay. One of the machine is, Windows machine. Okay. This particular computer machine or laptop or whatever it may be is having Windows 11 operating system, let's say. And there is one more computer machine. Let's say this is a Mac machine. Okay. Mac machine. Here Mac OS, okay, some version of Mac OS is there in this particular computer machine. And there is another computer machine, and there is another computer machine where a Linux operating system is there, okay? Let's say Linux Ubuntu is there here, okay? Linux Ubuntu flavor operating system is there here. Now, if you write the code, let's say in this particular Windows machine, you have written some code, guys, okay? You have written some code here, some Java code you have written, okay? Some Java code, programming code you have written. Now, you can run, you have written the code here and you can run it here and it will work fine in the Windows operating system containing machine. Now, tomorrow, you want to create the same code in another Mac machine. You don't have to create again, guys. Okay. Same code you want in Mac machine. You don't have to create it specifically for the Mac operating system, because whatever the code that you have written on a Windows operating system using Java programming language will also can be simply copied and will also work, and you can directly run in the Mac operating system also without needing any changes. And again, the same code that was there in the Windows can also be copied into the Linux Ubuntu. Though it is not written in the Linux Ubuntu operating system containing machine, but it has been written originally in the Windows 11. But without doing any changes, you can copy this code into the Linux Ubuntu and can run it, and it is going to work perfectly fine. This what makes Java a platform independent programming language. Okay. Java is a Java is a platform independent programming language. Okay, so I told you how Java is a, I told you like why Java is a platform independent language, okay? Programming language. Because you can write it anywhere and run it anywhere without again creating the code separately for different machines and all. Just have to write in one of the machine and the same code can be copied into multiple machines and can run there also. So you don't have to recreate the code specially for different machines and operating system. That's what makes Java a platform independent programming language. But how Java is able to achieve this kind of thing, how Java is able to get this kind of result where it has become platform independent programming language. What are the things in Java that makes it a platform independent programming language? What is a technique that Java is using for making itself or stating itself like it is a platform independent programming language? For that, you have to understand something, guys. Okay, that's what I'm going to cover here. Okay, that's what I'm going to cover here, guys. How Java has become a platform. Why you understood why Java is a platform independent programming language? You understood because you can write it anywhere and the same code you can copy paste instead of recreating again in another operating system or machines and run them as it is there. That makes the Java, okay, platform independent. Okay. Why is okay? How? The question of how Java has become a platform independent, what makes Java a platform independent programming language is still something there pending for you to understand. Okay. How Java has become a platform independent programming language, I'm going to explain. Let's say, guys, in one of the machine, okay, let's say this is one computer machine. Let's say this machine, let's say this is Windows 11 machine, okay, Windows 11 OS. In this machine, you have written some Java program, okay, for adding whatever the Java code I have written, right? For example, okay, let's say this is some Java code. I'll give you with practical things also. I'll just give you a feel of what exactly is happening. Instead of making it completely theoretical, right, I'll make it engaging. So in this one of the Windows 11 operating system containing machine, you have written a Java file containing some Java code here. Okay, let's assume that this is a Java file having the Java code. Okay, this is a Java file having the Java code. You have written it. Okay, so for example, already we have experimented this, right? In my downloads folder, it is already there. You see here, I'll delete all this stuff and okay, so let me delete this and let me delete this and so how all the things have started here, we have already have a Java file, right? Uh, or we can create something from scratch also. For example, here I'll create a text file. Initially, I'll create a text file. I'll not name it anything. Just open the text file, guys. Once I open the text file, right, into the text file, I have to write some Java code. Since I have not taught you what is Java and all the fundamentals of Java programming or code, I didn't taught you so far. What I'm going to do here is I'll go to one to like ChatGPT or Google, whatever it is, and ask it. Okay, give me a sample Java program to run and make sure it is my first program I am running and it should be very simple. Okay, very simple and okay, simple to use. Like that, I'll write some prompt, guys. Definitely, it's going to. You see, generally, whenever you write this kind of prompts, right, Java will give you this ChatGPT will give you hello world kind of programs only, guys. Okay, so you see, this is the code it has generated, guys. Okay, this is a simple Java code that it has generated. So copy this code, guys, without any understanding or something. Just copy this code, guys. Already Java software is already installed in my machine, right? In the previous sessions only, I showed you like how to. And it also has given, if you run this particular program, you're going to get this hello world as output. Whatever the hello world is there in the program, right? That is going to print it in the output. It is same. So anyhow, without worrying about that, just copy this Java code, guys. You can also copy from here. For now, I'm copying like this. Once I copy this Java code, whatever the text file I created, right? I'm pasting there. Okay, this is a Java code I have created. Okay, now this is a text file, right? Okay, so I'm going to save this. Okay, I'm going to save this and I'm going to name this Java file as a the same class name. Copy this class name and simply say file, save as, and again go to the same downloads folder. In the downloads folder, give that name, hello world, and give the extension as .java here, as I already explained in the previous sessions, and say all files and click on save. The moment you click on save and just close it, guys. Okay, you don't have to do anything. Now go to the same folder and see that with the given name hello world.java, Java source file got created. Now this text file is not of any use. You can delete that. Now this Java file has the Java code that we have written. You can also open this if you want to cross check again. You can open this in Notepad and see whether the code is still there or not. You see, in the Java file, this particular code that I copied from the ChatGPT is still there. Okay, the given prompt is still there. Now, now originally I have written the Java code, right? This Java code will run in my machine. Yes, This Java code is created in my machine, computer machine only. So it should work in my machine. So it should be able to run in my machine, right? So here is the thing. Okay. Now for me to run this, okay. So here, what was the Java file here, guys? The name of the Java file is hello world. Hello world.java is the name of the file we created. In this Java file, some code is there. That code also I showed you. But if you want to run this code, what you have to do first? If you want to run this code that is there in the hello world.java file, what you have to do? You should not run it directly, guys. You have to first compile it, okay? What is the process that will come in between? Okay, we have to compile the Java file. Okay, we need to compile the Java file using what? There's something known as Java compiler. There's something known as, when you install Java, Java will come along with the Java compiler, guys. This is one of the components of Java. Okay, this Java compiler. Okay, that is nothing but in the previous session I explained, right? Java c.exe file, other words. Okay, Java c dot. That's why I told you, right? If you go and watch the previous session where I explained all this stuff, you can know that here the Java file need to be compiled. Okay, with the help of this Java c.exe development tools. Okay. So anyhow, the compilation process will be there. How to compile practically, I'll show you, okay? Without worrying it about, here Java file is there. I want to compile it with the help of thing, okay? With the help of Java compiler. For that, I'll just type cmd here in this path, and the command prompt will open at the location where this downloads folder, this file. Okay, under the downloads folder of this machine, we have this hello world.java. At this location where this file is available, the command prompt has directly opened. Now what I'm going to do here is, I'm going to use a Java compiler. Okay, for that we have a command that is Java C. Since the environment variables are already set, we can directly run the Java command here, that is Java C. This command will invoke this part, java c.exe, it will invoke, and as part of this, compilation will happen. Okay, and following this, which file I want to compile? The Java code is there in this hello world. Okay, hello world.java is the name and extension of the file that I want to compile. So the code that is there in this Java file will need to be compiled. I cannot directly run this Java code inside the Java file, guys. Whatever the Java code in the Java file need to be compiled first. When I press enter, you see, I didn't get any output, but it got compiled, but the output is there here. You see, in the downloads folder, another file got created as part of the result of this compilation using the Java C. You see, hello world dot class file got created. Okay. So here, that's what happened. What happened here? Okay, a dot class file. Okay, when I use this, what was the command I have used, guys? Java C. Okay, hello world dot Java file I compiled, right? Hello world dot Java I compiled, right? This is what I have done. For using this Java c.exe for Java compiler, I have used Java C hello world dot Java command at the location where this hello world dot Java file was available. The moment I have done that, what happened here? This particular Java code that is there in the hello world.java file got compiled, and here another file got created. What is the name of this file? Here, what file got created, guys? Here, which file got created? Hello world dot class file got created. Okay. Here, what happened? Okay. Here, hello world dot class file got created. But here, will there be any Java code here? No, this is not Java code. The moment you compile here during the using this command and all, here Java code has been converted into the bytecode. This is called as a bytecode, guys. Here Java code is there. Here in the first step, what is there? Java code is there. Here Java code is there. But here what is there? Here bytecode is there. Bytecode is there. Okay. Do you want to see the bytecode? How does it look like? You see, on compiling using this command here. Okay, the second step before directly running the Java code in Java, we have to first compile it. Okay, this compilation is something related to the platform independent nature of the programming of the Java. Okay, how the Java will become a platform independent programming language, because this is one of the area where without compiling Java cannot become a platform independent. Okay, the reason why the compiling is happening here is to make the Java a platform independent programming language. Compiling process got introduced into Java, guys, where this actual Java code which was there in the English kind of language has been converted into the bytecode. So how the bytecode will look like? Just this dot class file got generated on running this Java C command, right? Now right click on this and select open with and notepad or something. You will see the bytecode now. Okay, let the notepad open, and you see this is the bytecode. You see, it's not completely English, guys. Some symbols are there. You see different type of symbols. Some part of the things are English, but most not complete thing is in English. Combination of symbols and English is there, and we cannot understand this. Can you understand this by looking at this? Can you understand this? We cannot understand this, guys. Okay, we cannot understand this. So then if you are not able to understand this, why did you compile? It's a question you are getting, right? So the answer, you have to wait for this answer, guys. Okay, for you to get the answer, why the compiling is required, why to compile something to convert the English understandable language to the bytecode. All the answers are going to be clear for you in a while. Once the compilation is over, okay. Once the compilation is done, then you need to run the code, right? Then you need to run the code. How do you run the code? How do you run the code, guys? JRE of the Java software will run this code, right? JRE part of the Java will run this code, as I already covered in the previous session. You see, JRE will run this code. Okay, this will be the you know this component of Java is responsible for running the code, guys. Okay, here development tools of Java will only compile the code and convert the Java code into the English format to the bytecode. Now JRE need to run the code. Okay, JRE need to run the code. In order to run the code, what you are doing here, if you go to this file here and same location, okay, command prompt, and if you want to run this time you have to use Java space the name of the dot class file. What is the name of the dot class file? Here you don't have to say dot class here. Java space hello world means java.exe will be invoked. Okay, here java.exe is there in the runtime tools of JRE, right? This particular file will be invoked, and that particular file will run the Java code. But how? I'll explain later. Okay, if you run that, you got the output. You see, the program has successfully run in your computer machine. In your computer machine, it has been run. This is okay. To run this directly, it's okay. But you see, in your computer machine, this particular code has been run with the help of JRE's java.exe file, and we got the program output also, whatever we thought should come as the output. That is all good. But still, how it has become, in my machine it is working as it is, that's okay, fine. But what is needed is, what is needed, guys, is just understand this. I may not have to, okay. So what will happen here is, okay, what will happen here is, the code has been written in Windows 11 computer machine, but I may not run in the same machine. Like this, I may not run in the same machine. For running the same machine, this much is enough. Java.exe of the Java is enough, guys. Okay. Whatever the code that is written in your machine to run in the same machine, Java.exe file is enough to run it. That's okay. But the problem here is, in order to make the Java a platform independent programming language, there's something known as JVM, guys. Okay. Why JVM all? I'll tell you. Okay. So what happens here is, let's say, guys, you want to run the code in Mac machine here. The code has been written in the Windows 11 machine, but you want to run in the Mac OS machine, okay? Or you want to run the code in the Linux, okay? You want to run the code in which machine? Linux, Ubuntu machine. Or you want to run the code in which machine? Other machine is? Or you want to run the code in which machine? Or you want to run the code in which machine? Let's say you want to run the code in, let's say, Windows 10 machine, okay, which is different from Windows 11 or whatever it is, okay, no matter what. So here I'll pick this here and make it here, okay, and I'll pick this here and make this here. I'll pick this here and drag this here, okay. So the code has been originally written in the Windows 11 and it need to be compiled for a reason. And when compiled, the Java code that is written in English has been converted into the bytecode. All good. But it has been converted to the bytecode for a reason, guys. Okay, because to make the Java a platform independent programming language, compiling is needed and the original code should be converted into the bytecode. And now the process is not ended, guys. By converting into the bytecode, who will understand this bytecode? Who can understand the bytecode? The only person who can understand the bytecode, as I already covered in the previous session, is JVM component of the JRE. In JRE, we have JVM, right? This JVM can understand the bytecode. Okay? Only the JVM can understand the bytecode. How can we install the JVM? Do we have to install JVM? No. You don't have to install the JVM separately, guys. When you install Java JDK in Mac OS, what happens? JVM related to Mac OS, okay? JVM which can communicate with the Mac operating system will be installed, okay? Will be installed, okay? If you, what about Linux? Here in Linux also you'll install Java, right? will here as if you have installed Java in Windows 11 machine. Similar way, you will install Java in Mac machine, or you can install Java JDK or Java in. Okay, you will install Java in Linux, Ubuntu OS machine, and JVM. When you install Java in Linux Ubuntu, JVM specific to Linux Ubuntu will be installed. Okay. So this, okay, and again, if you install Java in Windows 10 OS containing machine, then JVM specific to Windows 10 OS, or which can understand Windows OS, which can communicate with on Windows OS, will be installed. And if you install, if you install Java in Windows 11 OS containing machine, JVM, okay, specific to Windows 11 OS will be installed, okay, which can communicate with the Windows OS installed machine will be installed, okay. So this is what is happening, guys. You see, Java software is not the same for different operating systems or different machines. Okay, if you go to the thing OS, for example, Oracle website is the place from where we are installing the Java, right? Downloading and installing Java, right? Let's revisit the website again. Go to the products, go to the Java, go to the download Java, and take any particular version of the Java. Let's say JDK 21. You see here Java for Linux is separate, Java for Mac OS is separate, Java for Windows. Depending on the type of the machine, you have to download the Java, right? You see, if you select Windows machine means you have to download this, any of these things. Okay. So Java for Windows is different from Java from Mac machine. Java from Windows and Mac are different from the Java for Linux machine. Like that, the things are there, guys. Okay. Things are there. That means when you install the Java on a Windows machine, JVM specific to the Windows machine will be installed. When you install the Java in Mac machine, JVM along with the Java, JVM also will come. Okay. Along with Java JDK, JRE will come. In that JRE, JVM will be there, but JVM will be specific to Mac OS. Okay, JVM, which is which can communicate with the Mac operating system containing machine, will be installed. When you install Java software in Linux Ubuntu, with that Java of the Linux Ubuntu, JVM, which is specific, which can understand the Linux, which can communicate with the Linux Ubuntu, only will be installed. When you install Java in the Windows 10 OS or Windows machine, JVM, which is specific to the Windows OS or Windows machine, will be installed. That means JVM which can communicate with the, so that's the reason Java is different from different. Okay, the kind of Java that you have to install will be different from different operating system, guys. This Java software is different. This Java software is different because based on the operating systems. Okay, so while installing, we have to make sure in which machine we are, and accordingly we have to download the Java for such kind of machine and then install. That's why we are doing like that, because JVM specific to that particular machine will be installed. Okay, now who understand this bytecode? The reason why we have compiled this Java code into the bytecode is that bytecode is now universal. JVM, which is related to, which can understand Mac OS, can understand this bytecode. JVM, okay, it's like a translator, guys. Okay, bytecode is like a translator that JVM can understand. Okay, so JVM specific to the Linux Ubuntu can understand the bytecode. The same bytecode can be understood by this JVM, which is specific to Mac OS. The same bytecode can be understood by the JVM, which is specific to this OS, okay, which is specific to this OS, and the same bytecode which is converted from the Windows 11 Java code to the bytecode can be understood by the JVM for this Windows machine. Okay, so that's the thing, guys. Okay, that's the thing. So JVM can understand this bytecode, and now JVM specific to the operating system is there. Communication also will happen to the machine. Now, what the JVM is doing here? JVM will convert the bytecode. Okay, on compiling process, when you compile the code, when you compile the Java code to the bytecode, right? The bytecode, okay, bytecode can be understood by whom? JVM of that machine. JVM will convert the bytecode into, can understand the bytecode and convert the bytecode into machine code. Okay, machine code means Mac OS machine code. The machine code that Mac OS can understand. Okay, that's what is the specialty of JVM, guys. Okay, JVM will convert the JVM will convert the bytecode into the machine code that macOS can understand in this case. Okay, here the JVM specific to Linux Ubuntu JVM converts to machine code that Linux Ubuntu OS can understand. Okay, I'm just trying to you know save some space here. That's okay. Here, what about this? Here, JVM will convert the bytecode, this particular bytecode, into the machine code that Windows Windows OS machine can understand. Okay, machine understandable code. It will be converted. Machine understandable code will be generally, zeros and ones, guys. Okay, like 0011, 1011, like this. It will be zeros and one. Here also zeros and ones only will be there. Here also zero. This code can be understood by this machine. This code can be understood by this machine. This ones and zeros can be. It can be different. Okay, it can be different. Okay, it can be different from different JVMs, how they are converting according to their machine understandable code. The JVMs will convert. So now once the JVM can understand the bytecode and convert the JVM can understand this bytecode and convert that bytecode into the machine code. This machine code will be run on this particular Mac operating system containing machine and the program will finally run. You see, though the program has been written initially on the Windows machine, it can be run on the Mac machine because of the conversion to the bytecode, and bytecode can be understood by JVM, and accordingly JVM specific to that particular operating system will convert according to the machine understandable code of that operating system, and the instructions will be run here and the program will be run and we'll get the output here. Because of that we'll get the output here. Okay, we'll get the output here also. Machine understandable code of that particular machine JVM will convert and from bytecode to the okay, and then so intermediary code is bytecode, guys. Okay, original code is a Java code, intermediary code is a bytecode. This bytecode can be understood by JVMs of that particular machines operating systems, and converted to the machine code that their machine operating systems can understand, and will run the code and will get the output. Finally we'll get the output. Okay, no matter where you are writing the code, you are writing the code only once, but you can run the same code in any of the operating system. Because of this is what makes the Java a platform independent programming language. Because of this only Java has become a platform independent programming language. Okay, hope you are able to understand, right, how the Java has become a platform independent. This is the underlying technology that Java, this is the reason why you are compiling the code. A lot of people don't understand why the Java code need to be compiled then run, because without compiling this kind of feat will not be possible, where okay, intermediate code cannot be generated that can be understood by any JVM of the any machine having any operating system, which by default, which actually results in making the Java a platform independent programming language. This actually makes the Java a platform independent programming language. Okay, platform Java. Okay, this is what makes Java a platform independent independent programming language. This how what you have to understand, guys. If you are learning Java in depth, all these concepts need to be covered. Okay, that's the reason I'm covering. Though it looks like a theory, but it's kind of very interesting concepts, guys. Okay, how the Java is becoming a platform independent and all those stuff. Now the story has not ended, guys. The story has not ended here. You got the answer, like why Java is platform independent here. You got the answer here, like why Java is a platform independent programming language. Now you got an answer like how Java has become a platform independent language. Now in this, at a high level, I listed down JVM will convert bytecode into the machine level code according to the JVM of that particular operating system machine I mentioned. But internally, what makes JVM? How the JVM is converting the bytecode into the machine level code. Okay, at a high level I mentioned here, but what actually goes through the process you need to understand now. Okay, how the JVM is converting the bytecode into the machine level code. What is the process that? Okay, here what I'm going to explain, guys. Third part is, okay, the third part is, let me draw here. Okay, so I'll just dig deep into this JVM part. Okay, at a high level I have to explain how the how is done, but again, if I zoom in a bit into the JVM component of this Java, but how the JVM is actually converting the bytecode into the machine level code, I didn't explain. Okay, that I'm going to explain here. How JVM, okay, is converting the bytecode into machine level or machine understandable code. Okay, this is what we need to understand next. Okay, so in order to understand that, already we have seen this previous session. This diagram was created in the previous session where you see in the JVM different components are there, right? Class. You see java.exe file will use these components to run the Java code. Okay. And during this process, what happens here? What are the different components of JVM? Class loader subsystem, runtime data areas, execution engine, native library. These are the and many other components may be there. These are the four components, high level components I mentioned. In this, one of the component I'm going to zoom in is execution engine. Okay, which component, guys? In JVM, we have a component known as in JVM. Let's assume that this is JVM. In JVM, we have one of the components. Okay, one of the component known as what, guys? Okay, one of the component is nothing but what, guys? Execution engine. Okay, there is one of the component in JVM known as execution engine, guys. Okay, there is a component in JVM known as execution engine. What this component will do, what this component, in this one of the components of JVM, there are different things, guys. Okay, there are three items: JIT. Okay, JIT compiler. Okay, then interpreter, Java interpreter is another one. Okay, interpreter. Then other one is garbage collector, garbage collector, garbage, garbage collector. Okay, like this, different components are there. You can see here, uh, here in JVM, in the execution, there are different components in JVM like this: class loader subsystem, runtime data areas, execution engine, and native libraries are the different components, and maybe other components also can be there. In that, one of the component of JVM is execution engine component. In that execution engine, what is there? Java interpreter is there. This one is a Java interpreter, guys. Whatever I have drawn here, this is a Java interpreter. And apart from the Java interpreter, what else we have? Apart from the Java interpreter, we have Java compiler. Okay. Apart from the Java interpreter, we have Java compiler. And apart from the Java compiler, we also have one more thing known as garbage collector in the execution engine component of the JVM. Okay. Here other components can be there. Other components will be there. And along with this other components, we have execution engine component is also there. Execution engine component is there. In this execution engine component, we have these three items again. One is Java interpreter is there, JIT compiler is there, garbage collector is there. So what is happening here is, okay, JVM is able to understand the bytecode here. JVM will understand the bytecode here. And the final output here is, okay, once this thing comes out of the JVM, what will come outside here? Here, machine level slash understandable code. Okay, that is in 11001110 kind of code will come outside. Okay, this code can be understood by the machine level code, or machine understandable code will be bytecode need be understood by the JVM and converted to the machine understandable code, so that this code will run on our computer machine, and the computer machine will give the output for us. Okay, our computer machine will perform the task and give the output of the program for us. That's what happens generally. But JVM, how the JVM is converting the bytecode into the machine level or understandable code here is because of these components. Okay, first component that I have to explain is the of the execution engine component. In that, in the execution engine component, one of subcomponent we have is the interpreter. This interpreter of Java will read one by line of the Java code. Okay, in the bytecode, right? In this bytecode, one by one line of bytecode. For example, this is a bytecode. You already know that. Open with Notepad. You can see the bytecode here. This kind of bytecode will be provided to JVM. In that, what is the first line? This line will be taken into picture. The first line will be taken. Okay, will be read by the first line will be read by the Java interpreter subcomponent of this execution engine component, and it will convert. Okay, line by line, it will be converted into this code. Okay, line by line, the bytecode will be converted to the machine line. Okay, interpreter, any interpreter, if you talk about, it will read line by line of the code. In this case, bytecode will be read line by line, one by one line, and it will be converted into this machine level code. But this process will take a lot of time. Okay, if the interpreter is reading only line by line and only after converting one line into the bytecode, again going to the next line and converting the bytecode, this process will take a lot of time. So that's where JIT compiler will come into picture, guys. Okay, that's where JIT compiler, to make this conversion of the bytecode into the machine level code faster way. Okay, to make it faster, JIT compiler, this is line by line. Okay, line by line, line by line conversion. Okay, conversion. But if you go solely with the line by line conversion of the Java interpreter of converting the bytecode into the machine level code, that process will become too much slow, and because of which the output will be delayed. Okay, the output will come with a kind of delay. That means you'll not get the output immediately. So that's the reason JIT compiler has come into the just-in-time compiler has come into the picture, where so there is a communication that will happen between the Java interpreter and the JIT compiler, where if Java interpreter while interpreting line by line finds some, okay, when Java interpreter scans the code, this bytecode, if it finds some repeatable code, okay, if in case this Java interpreter finds some repeated code, for example, this code and this code are same, assume that, okay, this code and this hello world is same, for example. Now what the Java interpreter will not convert such kind of lines. Okay, so what the Java interpreter will do is it will give the thing to the JIT compiler. It will say that I have already converted this kind of line. Okay, Java interpreter will communicate with the JIT compiler, saying that Java interpreter will say that I already have converted hello world into the bytecode. Now again, when I'm interpreting, right, when I'm interpreting, again I got the same kind of hello world kind of line. So since I already have converted, now you take care of it. Okay, this JIT compiler, what it will do, such kind of repeatable, which can be scanned together, and the identifier, it knows the answer already. Okay, so what should be the answer, what should be the answer of this bytecode, it knows. Okay, if it, what it will be done, Java interpreter will communicate to the JIT compiler, and JIT compiler will do it very fast. It will collect all the common things, okay, to reduce the load on the Java interpreter. JIT compiler will become smarter enough in identifying all that, scanning that bytecode, okay, and quickly converting the bytecode into the machine level understandable code based on its knowledge levels, and based on whatever the communication Java interpreter has done to this JIT compiler. JIT compiler will identify good amounts of good pieces of bytecode and convert them at a lot into the machine level code, so that Java interpreter need to work with only the lines that were not converted by the compiler from the bytecode to the machine level code. Okay, so to make the, you see, the ultimate thing about the JIT compiler is to speed up the process, somehow it has its own algorithm where it will communicate with the Java interpreter and identify some blocks of the code in the bytecode, which can be faster way converted into the machine level understandable code. Okay, whereas Java interpreter will be slow, line by line it will convert. Okay, whatever it cannot be identified at a go by the compiler and JIT compiler, and okay, just in time compiler. This JIT means just in time compiler. Okay, the full form of JIT is just in time compiler, we have to say. JIT means just in time. Okay, this compiler will help the Java interpreter in speeding up the process of converting the bytecode into the machine level code, okay, in a faster way, so that we can get the output of the code faster. Okay, that is the reason. And these are the things that are mainly, these are the two subcomponents of the execution engine component of JVM, which will convert the bytecode into the machine level understandable code. But garbage collector is there here for a different reason. That is, okay, that is, guys, let's say, let's assume our real world example of our house. Let's say you are staying in apartment, okay, and whenever you do your daily activities, right, lot of waste will come, okay, out of your house, lot of waste will come, and that waste, what you will do, you will not store it at your house, right? What you will do, that waste you will go down to your apartment, and some dustbin kind of stuff will be there. You'll put in that waste into that, and weekly, or 3 days, for every 3 days or by days, or weekly, some vehicle will come and collect all the waste that is there in your dustbins and clear, right? Here whatever the vehicle that is coming to your apartment to collect the garbage waste, right, okay, to collect your garbage, right, that is not happening immediately. Similarly, Java has a kind of garbage collector kind of program or algorithm, okay, which will clean clean the unused, okay, unused or after used kind of garbage, okay, which will clean the garbage left out after running the code. Okay, which whatever the garbage that is left out after running the code, right, or whatever the garbage that is left out as part of the code, right, at some point of time this garbage collector will come and clean the garbage. Okay, Java program will not clean. Okay, so initially when you are running the code, garbage will not be cleaned, guys. The garbage will kept on collecting, and the garbage collector mechanism or this component subcomponent of execution engine will come and clean it later part. Okay, so it may not happen instantly, but whenever it has according to the algorithm, it will come later and clean it and go away. Okay, that's what is a garbage collector. I'll explain more about the garbage collector later. This topic is something which need to be covered in depth in the later parts of the sessions. Okay. So I'll not cover here. Let me, you know, whatever the pending things, right, I'll just write down here so that I'll not forget garbage collector. Okay. Mechanism in Java I'll cover later. This particular part I'll cover later, but the main important JVM part, which is converting the bytecode into the machine level code, is being done by the Java interpreter and JIT compiler. JIT compiler is to speed up the process of converting the bytecode into the machine level code, whereas Java interpreter will read the bytecode line by line and convert. And to speed up the process, JIT compiler came into picture. Okay. So at a high level, if I say JVM will convert the bytecode into the machine level code, okay, because JVM can understand the machine and it can communicate with the machine according to its machine in which it is installed and available. It will convert to that particular machine level code. That's why Java has become the platform independent programming language. But how the JVM will convert the bytecode into the machine level code? For that, we have to dig deep into the Java interpreter and JIT subcomponents of the execution engine component of JVM. Then only we'll understand this process. So these all, with all these things, you would have understood now like how the Java has become a platform independent programming language, guys. You see, with this knowledge, right, you can answer hell lot of questions, interview questions, okay, from the Java here, okay. So how the Java has become a platform independent programming language, what makes it, how it, why Java is, how Java is a platform independent programming language, and what are the different components in JVM which will convert the bytecode into the machine level code, and okay. So internally JVM, if you do the postmortem of JVM, you'll get all these items, guys. Java interpreter, JIT compiler. Okay. Java interpreter will identify the repeated code and some blocks of the code that it can identify and immediately faster we convert into the machine level code. Okay, to reduce the time. Okay, so that's the things, and garbage collection also I mentioned cleans the garbage at later point of the time in the code. So these are the reason, guys, and finally you see, when you install Java software in different operating system containing machines, different Java software will be installed, guys. Okay. Java software that is needed to be installed in Windows machine will be different. Java software that you will install in Mac machine will be different. Java software that you have to install in Linux machine will be different, because when you install a different software in different type of Java software in different machines, JVM specific to that particular machines will be installed. That is the reason Java has a different releases of software for different operating systems. Okay. So, but program code will be same across operating system, because the program code will be converted to the bytecode, and the JVM of that particular Java installed operating system will convert the bytecode into the machine level code. That particular machine will understand. That's what actually makes the Java a platform independent programming language. Okay. So you see, in case of Java, a common software is not possible, guys. A common Java software cannot, you don't have a common Java software which can be installed in Windows machine. Same Java software can be installed in Linux. Same Java software can be installed in Linux. It's not there, guys. We have separate Java softwares for different operating system. That's what I'm going to say here. Without this, the platform independent concept will not be possible. That's why Java software is different from different operating system. And without converting the Java code into the bytecode also, platform independent nature cannot be identified. Now, since every type of Java that you are installing different operating system has its own JVM, specific JVM, which can understand the machine in which you are understanding, that bytecode can be understood by JVM and converted to the machine level code that particular machine can understand to conclude. Okay. So I have already concluded this topic now. So hope guys you have understood this concept in depth now. So how Java is a platform independent programming language. Apart from answering this question, right, you have learned a lot of, you got a lot of knowledge in this session, right? You got a lot of knowledge. You see, by digging deeper, right, lot of concepts will come, guys. But I am covering the Java in-depth session in a optimized way. Even though the sessions are kind of lengthy and lot of material is being shared, that doesn't mean that I'm covering complete content for you at a go. Okay, without leaving anything, leaving anything for later parts. I'm leaving all the pending topics. Otherwise, you can say pending topics or something here. All the pending topics will be explained here. Okay, left out topics or pending topics will be explained here, where we'll go in too much depth there. Okay, at this moment we should not go, because that will, you will not, you see, if you keep on doing lot of in depth, if you are learning, means again you will not understand also. Too much of knowledge is also not good, guys. Optimized way. Okay, it should be neither less amount or nor even like it should not be extremely more or extremely less, should not be there. In between, somewhere in between, I am just making an adjustment here. At what level I have to explain the concepts, I'm just deciding myself, and accordingly I am explaining, so that you will understand the concepts well. Whatever I'm not covering or whatever I'm leaving without covering, right, that will be covered later at any cost. Okay. So because this course is all about covering the Java in depth, at some point of time every topic will be covered. but this course is going to be planned in a proper way, so that optimized way we are going to cover the topics for you. Okay, though they are in depth, they are going to be still optimized also. Now, since you understood one of the advantages of the Java, that is how Java is a platform independent programming language. Okay, we have other advantages also that also will come in the pending list, guys. Okay, advantage and disadvantages of Java, which are not covered here as part of this, will be covered at some point of time in the course, or they will be covered at the end, okay, of the course based on the timeline and all. Okay, fine, they will be definitely covered. So that's all for this session, guys. In the next session, I am going to explain you. Okay, in the next session, I'm going to explain you the different editors for writing the Java programs, guys. Okay, so far we have used as basic, very basic editor like text file editor, but this one will not be used in real time. No developer will use the text file for writing and running the Java code in real time. So we generally use good type of editors, okay? Some good editors in real time for writing and running the Java programs that I'm going to cover in the next session. So this is going to be practical session. The next session is going to be practical session and theoretical session also at the same time. So let's see how it goes. Let's not worry about whether it is practical or theoretical, but it's going to be, slowly we are going to the practical direction, we can say for now, because okay, so we are going to see the different type of editors that we can use for writing and running the Java programs in the next session. So guys, that's all for this session. See you in the next session. Thank you. Bye bye.